MySQL Cluster is a technology providing shared nothing clustering and auto-sharding for the MySQL database management system. It is designed to provide high availability and high throughput with low latency, while allowing for near-linear scalability. MySQL Cluster is implemented through the NDB or NDBCLUSTER storage engine for MySQL. Architecture: MySQL Cluster is designed around a distributed, multi-master ACID-compliant architecture with no single point of failure. MySQL Cluster uses automatic sharding to scale out read and write operations on commodity hardware and can be accessed via SQL and non-SQL APIs. Replication Internally, MySQL Cluster uses synchronous replication through a two-phase commit mechanism in order to guarantee that data is written to multiple nodes upon committing the data. 2 copies of the data are required to guarantee availability. MySQL Cluster automatically creates O node groups from the number of replicas and data nodes specified by the user. Updates are synchronously replicated between members of the node group to protect against data loss and support fast failover between nodes. It is also possible to replicate asynchronously between clusters. This is sometimes referred to as MySQL Cluster Replication, or geographical replication. This is typically used to replicate clusters between data centers for disaster recovery or to reduce the effects of network latency by locating data physically closer to a set of users. Unlike standard MySQL replication, MySQL Cluster's geographic replication uses optimistic concurrency control and the concept of epochs to provide a mechanism for conflict detection and resolution, enabling active-active clustering between data centers. Starting with MySQL Cluster 7.2, support for synchronous replication between data centers was supported with the multi-site clustering feature. Horizontal data partitioning MySQL Cluster is implemented as a fully distributed multi-master database ensuring updates made by any application or SQL node are instantly available to all of the other nodes accessing the cluster, and each data node can accept write operations. Data within MySQL Cluster tables is automatically partitioned across all of the data nodes in the system. This is done based on a hashing algorithm based on the primary key on the table, and is transparent to the end application. Clients can connect to any node in the cluster and have queries automatically access the correct shards needed to satisfy a query or commit a transaction. MySQL Cluster is able to support cross-shard queries and transactions. Users can define their own partitioning schemes. This allows developers to add a E distribution awareness to applications by partitioning based on a sub-key that is common to all rows being accessed by high-running transactions. This ensures that data used to complete transactions is localized on the same shard, thereby reducing network hops. Hybrid storage MySQL Cluster allows data sets larger than the capacity of a single machine to be stored and accessed across multiple machines. MySQL Cluster maintains all indexed columns in distributed memory. Non-indexed columns can also be maintained in distributed memory or can be maintained on disk with an in-memory page cache. Storing non-indexed columns on disk allows MySQL Cluster to store data sets larger than the aggregate memory of the clustered machines. MySQL Cluster writes redo logs to disk for all data changes as well as checkpointing data to disk regularly. This allows the cluster to consistently recover from disk after a full cluster outage. As the redo logs are written asynchronously with respect to transaction commit, some small number of transactions can be lost if the full cluster fails, however this can be mitigated by using geographic replication or multi-site cluster discussed above. The current default asynchronous write delay is 2 seconds, and is configurable. Normal single point of failure scenarios do not result in any data loss due to the synchronous data replication within the cluster. When a MySQL Cluster table is maintained in memory, the cluster will only access disk storage to write redo records and checkpoints. As these writes are sequential and limited random access patterns are involved, MySQL Cluster can achieve higher write throughput rates with limited disk hardware compared to a traditional disk-based caching or DBMS. This checkpointing to disk of in-memory table data can be disabled if disk-based persistence isn't needed. Equals shared nothing equals, MySQL cluster is designed to have no single point of failure. Provided that the cluster is set up correctly, any single node, system, or piece of hardware can fail without the entire cluster failing. Shared disk is not required. The interconnects between nodes can be standard Ethernet, Gigabit Ethernet, InfiniBand and SCI interconnects are also supported. Equals SQL and NoSQL APIs equals, as MySQL cluster stores tables and data nodes, rather than in the MySQL server, there are multiple interfaces available to access the database. SQL access via the MySQL server, NoSQL APIs where MySQL cluster libraries can be embedded into an application to provide direct access to the data nodes without passing through a SQL layer. These include Memcached, Node.js/JavaScript, Java and JPA, HTTP/REST, and NDBAPI. Equals MySQL Cluster Manager equals, part of the commercial MySQL Cluster CGE. MySQL Cluster Manager is a tool designed to simplify the creation and administration of the MySQL Cluster CGE database by automating common management tasks, including online scaling, upgrades, backup restore and reconfiguration. MySQL Cluster Manager also monitors and automatically recovers MySQL Server application nodes and management nodes, as well as the MySQL Cluster data nodes. Implementation: MySQL Cluster uses 3 different types of nodes. Data node: these nodes store the data. Tables are automatically sharded across the data nodes which also transparently handle load balancing, replication, failover and self-healing. Management node: used for configuration and monitoring of the cluster. They are required only to start or restart a cluster node. They can also be configured as arbitrators, but this is not mandatory. Application node or SQL node: a MySQL server that connects to all of the data nodes in order to perform data storage and retrieval. This node type is optional. It is possible to query data nodes directly via the NDB API either natively using the C++ API or one of the additional NoSQL APIs described above. Generally, it is expected that each node will run on a separate physical host, VM or cloud instance. For best practice, it is recommended not to co-locate nodes within the same node group on a single physical host. Versions: MySQL cluster version numbers are no longer tied to that of MySQL server. For example, the most recent version is MySQL Cluster 7.4 even though it is based on contains the server component from MySQL 5.6. Higher versions of MySQL Cluster include all of the features of lower versions, plus some new features. Older versions, not in development anymore, NDB included in MySQL 5.1x source tree, MySQL Cluster 6.2 based on MySQL 5.1 first telco or carrier grade edition release. Supports 255 nodes, online table alter, replication latency and throughput enhancements etc. MySQL Cluster 6.3 based on MySQL 5.1b, includes compressed backup plus LCP, circular replication support, conflict detection resolution, table optimization etc. MySQL Cluster 7.0 based on MySQL 5.1c, includes multi-threaded data nodes, transactional DDL, Windows support. MySQL Cluster 7.1 based on MySQL 5.1d, includes clustered J and clustered JPA connectors, currently available versions. MySQL Cluster 7.2 based on MySQL 5.5, includes adaptive query localization, Memcached API, simplified active-active geographic replication, multi-site clustering, data node scalability enhancements, consolidated user privileges. MySQL Cluster 7.3 based on MySQL 5.6, includes support for foreign key constraints, Node.js/JavaScript API and an auto-installer. MySQL Cluster 7.4 based on MySQL 5.6, includes enhanced conflict detection and resolution, improved node restart times, new event API. Requirements: for evaluation purposes, It is possible to run MySQL Cluster on a single physical server. For production deployments, the minimum system requirements are for 3x instances/hosts, 2a, data nodes, 1a, application/management node, or 2a, data node plus application, 1a, management node. Configurations as follows: OS Linux, Solaris, Windows. OS X, CPU, Intel AMD x86/x86-64, Ultra Spark, memory, 1 GB, HDD, 3 GB, network, 1+ nodes. Tips and recommendations on deploying highly performant, production-grade clusters can be found in the MySQL Cluster Evaluation Guide and the Guide to Optimizing Performance of the MySQL Cluster Database. History: MySQL AB acquired the technology behind MySQL Cluster from Alzato, a small venture company started by Ericsson. NDB was originally designed for the telecom market, with its high availability and high performance requirements. MySQL Cluster based on the NDB storage engine has since been integrated into the MySQL product, with its first release being in MySQL 4.1. Competitors: Codeship provides Galera, a multi-master extension for MySQL that enables multiple MySQL nodes to handle reads and writes, synchronizing the writes on each node simultaneously. Galera is also available through Percona, called variously Percona Cluster, and XTRADB Cluster. Galera leverages a fork of the INNODB storage engine and custom replication plugins. MariaDB, a MySQL fork, now ships MariaDB Galera Cluster as its cluster solution too. Scalabase is a database software company located in Newton, Massachusetts, that works with next-gen apps to scale out relational databases by virtualizing, auto-sharding, a distributed database environment. Support: MySQL Cluster is licensed under the GPL v2 license. Commercial support is available as part of MySQL Cluster CGE, which also includes non-open source add-ons such as MySQL Cluster Manager, MySQL Enterprise Monitor, in addition to MySQL Enterprise Security and MySQL Enterprise Audit. References: Cluster CGE. MySQL. Retrieved on September 18, 2013. Oracle Corporation. MySQL Cluster Benchmarks. Oracle and Intel achieve 1 billion writes per minute. MySQL.com. Retrieved June 24, 2013. MySQL 5.6 Reference Manual 17.6.11 MySQL Cluster Replication Conflict Resolution. dev.mysql.com. Retrieved on September 18, 2013. Synchronously replicating databases across data centers. Are you insane? blogs.oracle.com. Retrieved on September 18, 2013. John Stevens, Mike Kruckenberg, Roland Booman, MySQL 5.1 Cluster DBA Certification Study Guide, pages 86, New Features of MySQL Cluster 7.2, MySQL Developer Zone, MySQL Cluster 7.3 is now generally available. An overview, MySQL Cluster 7.3 Summary, MySQL Cluster 7.4 GA, 200 million QPS, active geographic replication and more, MySQL Cluster 7.4 Summary, Todd Device. MySQL Acquiring Data Management System vendor Alzato. ComputerWorld.com. Retrieved November 5, 2012. External links. =MySQL Official MySQL Cluster Documentation, MySQL Cluster API Developers Guide, MySQL Cluster Demonstration, MySQL Cluster Datasheet, MySQL Cluster FAQ, MySQL Cluster Auto Installer Tutorial, MySQL Cluster Blog, Getting Started with MySQL Cluster, MySQL Cluster White Papers and Guides, MySQL Cluster Community Forum. Other Design and modeling of a parallel data server for telecom applications. Original MySQL Cluster design motivation.